So we've been doing some adding and subtracting with complex numbers. So today we're going to do some multiplication and division. So let's look at this first question. So let's say we have 3 plus 2i, and we want to multiply it by 2 plus I. Okay, so it's kind of like the double distribution that you've always done, except this time we're going to have i's. So we have 3 times 2, which will be 6. Then the 3 times the I will give us plus 3i. Then the 2i times the 2 will give us positive 4i. And lastly, those last two terms, the positive 2i here with the positive I here will give us positive 2i squared. Now what you have to kind of remember is, remember we talked about that I squared is equal to negative 1. So we're going to replace this I squared with a value of negative 1. So let's just keep going. So we bring down the 6. Now these two middle terms here are like terms, so let's add those, and that's going to be plus 7i. And then here we go. So we have plus 2, and then our I squared is negative 1. So that ends up giving us negative 2. And we're going to combine that with that 6 down here. So our answer is 4 plus 7i. And there we go. Okay, and that's how you multiply complex numbers. We'll try a few more. All right, let's try another one. So let's say I have 6 plus 5i, and I want to multiply by 6 minus 5i. Now, if you recall, these are called conjugates. Remember, conjugate is just a binomial whose middle term is the opposite of the first middle term. So we have 6 plus 5i. In the second set of parentheses, we have 6 minus 5i. It's just the sign in the middle that's changing, not both signs. All right, so let's double distribute. So 6 times 6, we get 36. If we have our outer terms here, we're going to get minus 30i. Our inner terms here will give us positive 30i. And then our two last terms will give us negative 25i squared. Now we have two things going on here. First thing is you should notice that these terms here are opposites of each other, so they're going to cancel each other out. Much like when we did conjugates with radicals. Okay, so that should always happen when we're multiplying conjugates. Those outer and those inner terms should always cancel one another out. Okay, so we're going to bring down the 36. That minus 30i and plus 30i disappear. And then down here we're going to have the 25. And remember again that I squared is negative 1. So then really what we have here is 36 plus 25. And when we add that, we get 61. And there's your answer. Okay, and that's how we multiply with complex numbers. Now we're going to move on to some division. All right, so let's look at some division. If I had 4 plus I, and I was dividing that by 2 minus 3i. Now we have a different situation here. It's much like when we had square roots in the denominator of fractions. We can't have that. You can't have an I in the denominator of a fraction either. So the way we got rid of binomial square roots, if you recall, was to multiply by the conjugate. So we're going to do the same thing here. So we're going to take the bottom and we're going to multiply it by its conjugate, because what this is going to do is get rid of that I. Okay, and if you're not sure, just hold on a second and you'll see. Okay, all right, now remember though what you do to the bottom, obviously you need to do to the top, so we're going to multiply the top by 2 plus 3i as well. Alrighty, so here we go. So we're going to double distribute up on the top, so we have 4 times 2, which is 8. Our outer terms, plus 12i. Our inner terms, plus 2i. And then our last terms, positive 3i squared. Here we go. All right, now we have conjugates on the bottom, so our outers and our inners should cancel out, but let's just, verify. So we're going to do 2 times 2, which is 4. Outer term is plus 6i. Our inner term is minus 6i. And then our last term is minus 9i squared. Okay. So let's just keep going, and we're going to combine like terms and see what we end up with. So we have 8 in the numerator, we have a positive 12i and a positive 2i, so that makes 14i. And remember again, over here and over here, that I squared is equal to negative 1. So that positive 3 is going to get multiplied by negative 1 in the numerator. So that's going to make that negative 3. In the denominator, we're going to have 4. As I said, these guys right here are going to cancel one another out because they're opposites of each other. And that negative 9i squared is going to become plus 9. Okay, and then all we have to do is just combine our like terms. So we have 8 minus 3, that's 5, plus 14i. My pen doesn't seem to want to work here. There we go. And then in the bottom, we're going to get 13. Okay, now, much like when we had the square roots and we simplified using conjugates, the same thing holds here. If you look at the numbers, the 5, the 14, and the 13, there's nothing that the three of them have in common. There's nothing that you can factor out or divide by, so this would just be your final answer. And that is it. Okay, so let's try just one more example of division. Alrighty, so let's say we have 5 minus 3i, and that's being divided by 1 minus I. Like in the last problem, multiply by your conjugate of the bottom, okay? And make sure that you repeat the same process up in the numerator as well. So again, we're going to double distribute. So in the top, we'll get 5 plus 5i minus 3i, and then minus 3i squared. Okay, in the denominator, now we have conjugates here. So we know that our outers and our inners are going to cancel out. By all means, you can double distribute. It's absolutely fine. But since I know that they're conjugates and I know the outers and the inners are going to cancel out, I'm going to take the shortcut and just multiply the two first terms together, which is the 1 times the 1, which obviously is 1, and then the two last terms, which would be the negative I and the positive I, which would give me negative I squared. Okay, so if you know that they're conjugates, you should know that their outer and inner terms are going to cancel. By all means, feel free to just, kind of skip that part. Alrighty, so then in the top here, I know that this is going to change to a positive 3 because I've got negative 3 times I squared, which we know is negative 1. So because that's going to be positive 3, with the 5 all the way in the far left, I know that I'm going to get 8. And then I'm going to add my like terms, and I'm going to get plus 2i in the numerator. Okay, in the denominator, once again, I know that I squared is negative 1, so if that's the case, then a negative 1 would be a positive 1. So we're going to have a 2 then in the bottom. Now here's what I was talking about. So you notice here that the 8, this 2, and that 2 all have a common factor of 2. So you can divide each of those numbers by a 2. So we'll get 4 plus I, technically 1i, but I'm not going to write it, technically over 1, which you really don't need to write either. So your final answer would just be 4 plus I.